Thank you all very much. I thank Joe Kember in particular for inviting me to come down here and have a few words this afternoon. I don't very often do these things, in part and only in part because I'm rather long-winded and I kind of object to the 20-minute British formula for doing actual work. So in aid of keeping my presentation on 300 years worth of magic lantern history in a shorter, I went into the basement, into the archive, to see if I could get out the old microtome and hopefully take some very thin slices of magic lantern history so that I'd kind of come out close to being on time. Let's go, guys. Slice 1, physics. The magic lantern was one of a number of instruments born as the natural sciences turned to experimentation and demonstration in the 17th century. These optical instruments, including the telescope, the microscope, the polemoscope, the magic lantern, and others, were first intended to demonstrate the magical powers of lenses to bring new and astonishing insights to the human eye. In describing the social history of the microscope, J.A. Bennett wrote that, in the early decades of the 17th century, the microscope seems to have been marketed and regarded as a toy, and there is little evidence that it was seen as having any potential role in natural philosophy. Robert Hooke then famously complained that, as late as 1692, that the use of the microscope was, and I quote, now reduced to a single votary, which is Mr. Leeuwenhoek, besides whom I hear of none that makes any other use of that instrument but for diversion and pastime. The magic lantern then took its place amongst the optical amusements of the day. Its makers were all craftsmen producing scientific instruments, including Jan van Muschenbroek, Johann Franz Grindel, I'll give you a picture of Grindel because he's rarely seen, Richard Reeve, and its early users were all figures associated with a new experimental science, such as Christian Huygens, Samuel Pepys, Robert Hooke himself, and many others. When Burkhard de Volder, the first university professor of physics in Europe, put together the first cabinet of physics at the University of Leiden, beginning in 1674, the magic lantern was included amongst its early instruments. The three major early collections of scientific demonstration instruments, those of Martin Triewald at Newcastle, of the Landgrave of Hesse at Cassel, and of Voltaire at Siri, all included at least one magic lantern, as did the somewhat smaller collections of the professional science lecturers, such as Wilhelm Jacob van Gravesande, Jean-Antoine Nollet, Pieter van Muschenbroek, Jean-Théophile de Solgues, and a half a dozen others. There are only a few records of very early lantern shows. Samuel Pepys saw a demonstration of the lantern on the 19th of August, 1666, which he described as very pretty. The best-known exhibition is that of Johann Franz Grindel in Nuremberg, which was recommended to the traveler Charles Patton by none other than Johann Georg Volkkammer, later president of the Leopoldina. Patton's report of a natural and lively country wedding, of the air filled with all sorts of birds, almost after the same manner as they are usually painted around about Orpheus, and of a stately palace and the gods of antiquity, probably including this representation of Bacchus, made such a strong impression on Patton that 3 years after leaving Nuremberg, he recommended Grindel's show to the son of a friend in Bremen who was on his way to Nuremberg, along with a very short list of other prominent attractions in the town, including the Neptune Well, the City Library, the house in which Albrecht Dürer's pictures were exhibited. Strong associations indeed for the magic lantern at its birth. About 20 years later, surviving lantern slides from Charles I, Landgrave of Hesse, tell a more pointedly political story. It seems clear that the Landgrave used his 4 magic lanterns for after-dinner political amusement, as one series of slides illustrates satirical portraits of French leaders involved in the revocation of the Edict of Nantes in 1685, which expelled the Protestants from France. These slides were based on a series of 24 satirical prints by Dussart called Les Heroes de la Ligue, published in 1691 in the Netherlands. It would seem that in having these prints repainted as lantern slides, the Landgrave, who saw some 4,000 Protestants welcomed into Hesse following the revocation of the Edict of Nantes, could revel in the mockery of the French bishops and other conservatives with his dinner guests, if they were the right dinner guests, and without taking up any wall space or any permanent installation in his home. Another 3 decades later, an after-dinner lantern show given around 1735 to the British diplomat, who was then director of the Hamburg Opera, Thomas Lediard, was again a symbolic representation of the virtues, as represented in natural science. Lediard and his unidentified host began by examining the paintings gallery, after which the ambassador was invited to view the wonderful operation of a curious Laterna Magica, the invention of a very great artist, and was taken to a specially prepared room where Lediard enjoyed a vision of the most beautiful firmament I had ever seen, the setting of the sun after a fine day, and soon after, the moon rising in a clear horizon, and the stars appearing bright and twinkling, as on a frosty night. Lediard's description continues at some length, over 5 pages of the book in which it was published, as he elaborates on representations of pride, envy, war, poverty, humility, amongst others. For us, one small detail is particularly telling here. As he recounts at one point, I observed around the globe a motley colored transparent ether, in which I perceived 7 figures hovering near the surface of the earth, so small that with the naked eye I could not make any distinction between them. But upon making use of a perspective which I had in my pocket, I perceived that one, which seemed superior to all the rest, was the figure I had frequently seen painted to represent the goddess of riches. I was preparing to take a more exact view of the figures with the help of my glass, when my friends told me I need not give myself the trouble. I should soon see them all distinct and separate as the Magic Lantern show progressed. So here again is that optical instrument as an item of fashion, carried everywhere by a gentleman who was ready to make closer observations of his immediate surroundings with his trendy optical instrument. We need to remember that even in the 18th century, the university physicist was normally required to give a series of public lectures and demonstrations. In effect, the university physicist was required to be a showman. In Vienna, for example, the appointment of professors of physics to the university was made under a law of 1774 that flatly stated that they had to strive for the necessary popularity. Abraham Gotthelf Kästner, longtime professor of natural history at Göttingen from 1756 onwards, actually gave up teaching physics because most of his students, quote, only wished to see physics, not to learn anything about it. Here again, the instruments of science in daily use in daily life, as the wonders of science appealed to the educated, social, curious class that Barbara Stafford described as using encyclopedic grab bags of conjuring tricks, amazing feats with coins, dice, and cards, experiments with chemical and optical apparatus, mathematical puzzles that were compilations rapidly spreading know-how from capital cities into the provinces. Now, I promised some footnotes to my comments, and my first footnote will strike attentive listeners at the workshop who will have noticed that across most of the first century of its existence, there is no mention here at all of the Lantern of Fear. The Lantern of Fear was a characterization of the magic lantern in its earliest days, which came from a private letter written by the Paris engineer and aficionado of optics Pierre Petit, that's part of his letter, to his acquaintance Christian Huygens in Leiden in 1664, as he was attempting to make his own magic lantern, and he used the phrase lanterne de peu as he asked Huygens about how the lenses in the instrument were arranged. This letter was only published in 1891 and became part of lantern history about a half a century later. But there seems to be, half a century later, but lantern historians in my generation have made much of Petit's characterization, using it as a central metaphor for the instrument. But there seems to be very little evidence of all this lantern of fear in the first 75 years or so of lantern culture. The uses of the lantern that we know about were limited to noble amateurs, visible representations of the wonders of nature and of gods, suggestions for instructional use, as suggestions were made by Gottfried Wilhelm Leibniz in 1675, Johann Zahn in 1686, and Johann Conrad Kreiling, the dean of the faculty at Tübingen in 1705, who suggested the preparation of lantern slides for the teaching of history, geography, natural history, and even mathematics. So where's the lantern of fear? Possibly in the very early lantern shows of Thomas Rasmus and Volgin Stone, whose exhibition in Paris was seen by Pierre Petit, and whose lantern Petit was attempting to copy when he wrote to Huygens. But we know almost nothing about Volgin Stone or his exhibitions, even in Swedish. He was a native of Gotland. Almost nothing exists, and certainly very little about his optical work. For a figure who has had such a substantial influence on the culture of the magic lantern and its reputation. From the very beginning, Volgin Stone is without question a central topic for further research. Send in your best doctoral students, please. Slice 2. Chemistry. Moving quickly along to the middle of the 19th century, we can see clearly that the major shift in magic lantern culture was now away from the world of physics to the world of chemistry, specifically to the new world of photography. This is not just because of the addition of photographic slides to the lantern repertoire. The swift dissemination of photographic apparatus and knowledge, with its unprecedentedly rapid advance across Europe and America as a hobby, as a profession, and as the latest marvel of science, as an industry, and as a social and technical infrastructure, had a great and undervalued influence on how magic lanterns were made, sold, and used. Practical developments in photography, for example, in the design and manufacture of flat-field lenses in sharp focus across an entire plate, had a direct effect on magic lantern culture, as these lenses designed for cameras proved equally significant for projection and became the universal projection lens. But photography also bred new social institutions, not least in the form of amateur and professional clubs for every city and town, which opened up new opportunities for illustrated lectures of every description. Photographic culture also quickly generated an extensive commercial network that included manufacturers, dealers, agents, retailers, and studios, many of which were wholly new businesses that generated new suppliers of and new markets for the magic lantern. As a result, the locus of magic lantern culture, which at the beginning of the 19th century was still in the hands of scientific instrument makers, began after mid-century to shift towards the new photographic networks, which would quickly become the dominant factor in magic lantern culture. Most of the principal makers of magic lanterns in the middle of the 19th century were companies founded as suppliers of photographic materials. A good example is the firm of Edward Liesegang, founded in 1854 in Elberfeld as a manufacturer of photographic plates and papers and a supplier of photographic chemicals. By the time the firm moved to Dusseldorf in 1873, the manufacture of cameras, magic lanterns, enlarging apparatus, and other photographic accessories had been added to their stock. By around 1880, the firm had become a specialist in projection apparatus, with a full line of Psyopticon lanterns, megascopes, dissolving view lanterns supplied for school, home, and professional use. By the turn of the century, their picture archive offered some 250,000 slides for purchase or rental, many of them imported or purchased in bulk from other manufacturers. The firm of Romain Talbot would be another good example. A photographic supply house founded in Paris in 1855, which then moved to Berlin in 1870 because of the Franco-Prussian War. Talbot introduced the important American-designed Psyopticon lantern to Germany in 1873. 4 years later, they published, I'm a little ahead of myself here. Thank you. 4 years later, they published a combination photographic album, this is Talbot, and catalog of 2,000 natural science photographs intended for the preparation of lantern slides. By the turn of the century, Talbot was still a leading photographic manufacturer, noted for their hand cameras, and was as well a prominent lantern manufacturer with a stock of around 20,000 lantern slides. Ferrier and Soulier, the producers of glass stereoscope pictures, would be another example from France. The British partnership of Horn, Thornthwaite, and E.G. Wood, which took over the optical firm of Edward Palmer at his death in 1845, which probably built the first biunnial lanterns, as designed by Wood, were another company deeply involved in photography. William Henry Thornthwaite's A Guide to Photography was issued in 17 editions up to 1860. As the magic lantern slowly turned into a commodity in the later 19th century, the growing cross-border trade in magic lanterns can be exemplified by the firm of W. Butcher and Sons in Greenwich, a retail pharmacy founded in 1866, which began quickly to supply photographic chemicals and equipment, and then added to their stock magic lanterns, chromolithographed slides under the Primus brand. Butchers imported most of their vast stock from abroad, mainly Germany, and continued in business until the 1930s. It was on the foundation of the widespread use of magic lantern in photographic clubs and societies, with their monthly open slide evenings, that illustrated lantern shows proliferated and quickly moved across all sectors of society, as exemplified by the Band of Hope Union, the Salvation Army, dozens of other evangelical and persuasive groups. But what of the lantern of science and science in this new environment? As we've already heard today, the lantern became the principal instrument of lecturers in a variety of formal and voluntary educational endeavors. It became a standard part of the repertoire of science classrooms and the makers of educational demonstration instruments. Firms like James W. Queen and Company in Philadelphia, T.H. McAllister in New York City, Max Kohl in Chemnitz, Ligeti and Zamba in Britain, and a half dozen others were at the center of supply to both secondary schools and colleges with burgeoning science and engineering courses. For this market, the magic lantern took on some new forms. Introduced in Germany in 1873 by Professor Franz Emil Storer, Jr., the optical bench provided a space between the lamp house and the projecting lens where a wide range of subjects and experiments could be set out. Using a single projection housing fixed to a long, heavy base plate with a variety of lenses, holders, slide stages, and accessories mounted firmly on the optical axis of the device, the optical bench was a flexible and adaptable demonstration instrument. This Klassen-style optical bench forms large parts of the chandelier we have in the room adjacent. That's where all that stuff comes from. The optical bench was perhaps superseded only by the German introduction of the Universalapparat, or universal apparatus, a multi-purpose instrument that could be used by less expert projectionists amongst teachers and lecturers. These combination machines would provide a wide range of transparent lantern slides, opaque objects, microscope slides, and specialized scientific slides illustrating the properties of light, sound, waves, and other phenomena. They were a bit like the advanced hobbyists' combination woodworking machines of today, ingenious multi-purpose projectors that were intended to be an integral suite of projection capabilities, easy to convert from one purpose to another, simple to use in the classroom or lecture hall, and both more efficient in their use of space, as well as less expensive than purchasing several machines. So too did lantern slides take on new forms. Now elaborate movements could be exhibited in astronomical slides, which were provided for classrooms in the same educational institutions. The principal advantage of these slides, depicting the movements of the planets, the moon, or heavenly constellations, was that they were both significantly cheaper to acquire and significantly less prone to damage than the orreries which they replaced. Astronomical slides were also significantly easier to store away than an orrery, and easier to see enlarged upon a lecture hall screen. So here at the turn of the century, lantern culture had become integrated into a widespread and stable infrastructure that reached into all classes and all corners of society. The later 19th century has often been called the golden era of the magic lantern. In fact, the magic lantern was now so successful that it was about to generate some new specialisms, mostly again through photographic developments that would end up with its own disappearance. Slice 3, the cinema. The title of Slice 3 is a little bit deceptive, although I do want to deal a little bit with the movement of the magic lantern culture out of the chemical world of photography and into the cinema. I have written elsewhere, I hesitate to say, almost 20 years ago, that the magic lantern was not so much a precursor of the cinema as it was the environment into which the cinema was born, a milieu which nursed it through its extended period of invention to about 1903, the institution which provided its early business practices, and the medium with which the cinema coexisted for about 3 decades. From this perspective, the cinema was in its beginnings an extension of the magic lantern, an extension that later surpassed the lantern's technical boundaries and aesthetic vocabulary, at least in the storytelling, in ways that were unimaginable at the end of the 19th century. I would like to briefly propose here, however, very briefly, that the magic lantern survived the onslaught of moving pictures at the end of the long 19th century, but that it did so mostly in disguise. Photography was once again the main culprit in submerging magic lantern culture so that it disappeared from view. The groundwork for the first chapter of The Invisible Lantern was laid in the 1880s as photographers first began to seriously pursue the skill of enlargement. Early artificial light photographic enlargers were magic lanterns with a bellows between the slide stage, the negative holder, and the lens, with the image projected onto an easel. Sometimes there were two bellows, one on either side of the slide stage or negative holder. Essentially, when you see a magic lantern with a bellows, you are looking at an early photographic enlarger, although one that could have a double purpose and act as well as a projecting lantern. At the end of the long 19th century, this horizontal enlarger was turned into a vertical instrument, where it remained for the rest of the 20th century, universally known as a photographic enlarger. But really, the photographic enlarger is a magic lantern hovering vertically, unrecognizably, over its easel. The second chapter of The Invisible Magic Lantern also came from the photographic world, perhaps confirming just how securely married to photography lantern culture had become. This was the post-war victory of the small format photography, or substandard film, as it was called in those days. In other words, lightweight 35mm cameras and films, which now produced 2-inch by 2-inch slides, smaller, lighter, more convenient in every way than the formerly standard 3¼ 4¼ double glass lantern slides. These slides were often projected, but now by a slide projector, also smaller and more conveniently operated by electric lamps. The light slide projector and the Kodak carousel projector were the most familiar marks. The magic lantern stood invisibly behind these new instruments. The third chapter of The Invisible Magic Lantern was, of course, the cinema, the child that radically outgrew its parents. In the early years of moving picture work, the magic lantern was so ubiquitous that moving picture shows were sometimes very strongly advertised as not a magic lantern show. I couldn't find that image. I looked for that image hard. I've seen it. Vanessa has got that image, not me. But cinematic moving pictures were quickly strong enough to create their own culture, leaving behind very little evidence of their birth culture in the magic lantern, or their birth culture in physics. That's not so surprising, perhaps, if we go back to the known inventor of the magic lantern, Christian Huygens, the most significant scientist in Europe, aside from Isaac Newton. Huygens is known, amongst many other things, as the inventor of the pendulum clock and the maker of its most accurate early examples. But like those who today enjoy Facebook, Spotify, WhatsApp, and digital projections in the cinema and at home, who would expect Huygens to recognize, much less operate and analyze, the most accurate clocks of today? If you sat him in front of science's most important clocks now, such as this cesium atomic clock pictured here, he would have no idea whatsoever of what it was or how it works. That's progress, folks. Progress without nostalgia. Thank you for your attention.